Hello 3D Printing Club. This video will be part 1 of a tutorial on Fusion 360 in which we'll create a fan utilizing several of Fusion 360's features, and I'll give you guys tips and explanations along the way. If you are watching this, you should already have Fusion 360 downloaded. Unless you have a Chromebook, then you can use the online version. And hopefully all of you applied for the student license and received it. Without it, some of the features will be limited, so it's best to get that as soon as possible. If you don't have anything, if you don't have Fusion 360 or that license, the links are available on the Google Classroom. Once you have Fusion 360 open and a new design, you're going to want to start by saving the CAD. So type Control S, or you can click on that floppy disk icon at the top left. And then you can name it as fan or first CAD or anything you like. It doesn't really matter. And don't forget to frequently save your models, including this one, just throughout the video, because Fusion doesn't autosave. If you do forget to save and something were to crash, there are ways to retrieve those models. Okay, so now we're going to create components. Components are separate parts of your 3D model, and they allow for joints and just better organization. It's a good habit to start by creating all the components you need, but for this tutorial, we're just going to start with the first one. So eventually we will need two components that includes the base of the fan and the fan itself. But for now, we're just going to start with the first one called fan_base. So right click here on the main assembly. It should be the name that you saved this model as. And then type in fan_base for the component name and then click OK. You don't need to worry about any of those other options just yet. Okay, so next we're going to make variables, which Fusion calls user parameters. They're found under the Modify tab all the way at the bottom here. So copy these following variables down, that's on your screen, into Fusion. You can use the plus user parameter button. And then for the name, write down the exact same name I have. And then for the expression, that would just be the number. So variables are really useful when you're creating models where you don't really know all the measurements or when the measurements are likely to change. Because you can easily update these measurements just in this parameter area. And you should use these for all your important models. Sometimes on the lesser important ones, I just kind of skip over that. Anyway, once you guys finish copying those down, just click OK. Okay, so now onto moving in CAD softwares. So there are a few different ways to move. These include zooming, orbiting, panning, and then using the view cube. So you can zoom just like any other application. You use 2 fingers, a mouse pad, or you use the scroll wheel on a mouse. Orbiting, you can do that by clicking and dragging on the view cube. And the view cube's that little cube at the top right of the screen. And if you have a mouse, which I do recommend, it makes movement a bit easier, you can hold shift and then click and drag that scroll wheel button to orbit. So panning is kind of similar to orbiting on a mouse. You just don't use shift. So you click and drag that mouse scroll wheel button. And then if you don't have a mouse, you can't really pan very easily. You'd have to select that option at the bottom of the screen. But you can kind of mimic that movement by zooming in and out at different spots. And then finally, for the view cube, you can just click on different spots to orient the camera from a specific direction. Okay, so you may notice that there are many different sections and tabs within Fusion 360. I know it was really overwhelming for me at first, but many of these we won't really use. So the important ones to keep in mind at the top here are Create. So this allows you to create new 3D objects. And there's Modify. This allows you to change existing objects. Then there's Assemble. And this is used for joints. You don't use it too often. There's Construct, and that's used for making planes, lines, and points. And then finally, Inspect. Again, not used too often, but allows you to measure and analyze your model. Okay, so let's start creating our model. First, we have to select the fan base component, otherwise we're really not using those components, and then we won't even be able to use joints. If you do leave this video and come back at any time, make sure you have the right component selected, otherwise the joints and full assembly won't really work in the end. So to create a CAD, you have to start with a 2D sketch. Then from there, we can extrude that sketch into a 3D shape. Every sketch needs a plane, so we will need to make the origin visible. We can do that by expanding the fan base component and then click that eye icon next to the origin. So now that we see the origin, we can select that bottom plane, and if we right click it, you can select create sketch. So now that we're in sketching mode, there are several different keyboard shortcuts in Fusion that are specific for sketching. So the most important one is S. This isn't just specific for sketching, so you can use this wherever you are in the application. But it's S for search, so you can search for other functions that you need. Other important shortcuts while sketching are D for dimension, that will define a length, distance, or angle. Then there's also L, that will create a line. C will create a circle. R will make a 2-point rectangle. And then X is for making something construction, and we'll talk about that later. And then P is for project, that's also something we'll have to talk about later. And then T for trim, and that allows you to cut out unwanted parts of a shape. So just try keeping these in mind as you're sketching. For our sketch of the base of the fan, we're going to need a rectangle. So click R, and then remember that's for a 2-point rectangle. And we're going to select the first point to be on the origin. Then just drag your mouse up and to the right, and you'll see that the dimension is kind of highlighted. So you can type the variable base underscore SQU, that's for base square. And don't hit enter right now. You have to hit tab so that you can switch to the other dimension. And then type base underscore SQU again, and now you can hit enter. And then this should create a fully defined 50 by 50 millimeter square. So you may have noticed that the lines of the rectangle went from blue to black. So a sketch with blue lines like this one is not fully defined and can be moved or manipulated in some way. So as I move my mouse, I can still adjust these corners. I can completely change the shape or just move the entire object. A sketch with black lines is fully defined, and then therefore it's complete. So whenever you're sketching, make sure that all the lines turn black so you know that you're finished sketching. So now that we've finished our first sketch, you can click Finish Sketch. And this will take us outside of sketching mode. So here there are more keyboard shortcuts to keep in mind, and this includes, again, S for search. That's always an important one to remember. If you can't remember any of the other ones, you can always just search for them. Q is for press pull. Now this chooses between the most likely extrusion method based on the surface you selected. It'll choose between extrude, offset, fillet, and other ones. E is for extrude, and this just extends a 2D object. F is for fillet, and that will curve a model's corners. M is for move, I is for measure, and J is for joint. Okay, so now let's make our sketch 3D. You'll need to click Q for press pull, and then select the sketch that we just made. Select that rectangle. And now this will choose extrude, because remember press pull chooses between a bunch of different features, and that's just because we selected a sketch. We could have done this by just clicking E instead, but Q is a little bit more helpful. So type in base underscore HEI, and of course that's for base height, and then you can hit enter. And now you should have a 3D shape. So our next step is going to be to hollow out this rectangle. And I know it's technically a rectangular prism. I'm just going to call it a rectangle. So we're going to need to hollow it out to make a room for a fan inside. And keep in mind that there are like many different ways of creating the same object. So for example, we could have just made this a lot thinner and then built up walls around it. But the way I'll do it is much simpler. So as I mentioned before, every sketch needs a plane, but this can also include sides of an existing object. So you're just going to right click on the very top face of this rectangle and then create a sketch. So now that we're in this new sketch, click R to make a smaller rectangle. And for this example, it doesn't matter where you put these points, as long as they're inside the existing rectangle, because we're going to use the dimension tool. So hit D for dimension, and we're going to specify the distance between the outer and inner rectangle. So if you select the top edges of both rectangles like this, and then just click anywhere to place that dimension label. Then type base underscore THI for thickness and hit enter. So whenever you're using a dimension, you're going to need to click either 2 or 3 times. That last click is just to place the label, and it really doesn't matter where it goes. So now repeat this process of placing these dimensions, going around the rectangle, so 3 more times, until that sketch is fully defined. And you won't need to keep clicking D because the dimension tool will stay selected. And by the way, if you do know what projections are, you may notice that we didn't need them in this example, and that's because we chose the sketching plane to be on the object. So the edges from the object that we were using with our dimensions are already inside that plane that we're working on. So once you finish the dimensions of the rectangle, you normally hit the escape key to unselect that dimension tool. But since we're done with the sketch, you can just hit finish sketch. So I chose this method of hollowing out the object to show you that extruding can also remove parts of a model. So we're going to use Q to extrude the sketch. So click on the sketch that we just drew. And although you could just type a negative number, I'm going to show you a more useful method. So change the extent type of the extrude to object, as you can see here. Then move the perspective by panning or just using the view cube, so that you can see the bottom of the model. Now you can select that bottom face as the object to extend to. And this would cut all the way to the bottom of our model. So we're going to need an offset. So type in negative base underscore THI as the offset. And then you can finally hit enter. So it is important that you know how to cut into a model using extrude, and then of course using that object extent type. But there was an easier method to hollowing out this rectangle, and that uses the shell feature. I'll quickly demonstrate how to do this, but you don't need to copy this. So all you need to do is select shell, and then that top face of the model. And finally just type base underscore THI, and that'll easily hollow out any simple models. Okay, so now it's time to start working on the fan. You should save here, just as a reminder, and don't forget to frequently save throughout the video. So now we're going to make a new component called fan. Don't forget, just right click on the main assembly, name it as fan, and then click OK. So now hide the fan base's origin, remember just that I, like I'm doing here, and then show the fan's origin, so you'll need to expand the component fan, and then click on that eye. We will also select the fan to make sure that we are working inside that component. So in Fusion, we can offset, angle, or create new planes where we need to make sketches. We need to start the fan in the very center, so we're going to use a mid-plane for this one. Underneath the Construct tab, and that's the tab with all the planes and axes and points, select mid-plane, or you could just search for mid-plane. Now choose the 2 opposite outside edges of the fan base. It doesn't matter which ones, just as long as they're opposite. And you can even select those inside edges. And then this should create a plane in the middle of the rectangle. And once you do that, create a sketch on that plane. Don't forget, that's just right click and create sketch. So for this sketch, we will need to reference the bottom surface inside the hollowed out fan base, the one here. And because we made a sketch on a new plane, Fusion doesn't actually recognize this plane on our sketch. So we're going to need to project that surface as a line on our sketching plane. So hit P for project, and then orbit so that you can see inside of the fan base, like this. And then you can select that bottom surface. You can hit OK for the project, and now if we return to our original perspective, and you can just use that look at button all the way on the right, there will be a purple projection line that we can now reference. So one of the most important sketching features are constraints. These are at the top of the screen here in sketching mode, and there is a drop down to access more here. So these are used to define and constrain your geometry in sketches. Most are self-explanatory, but I will explain a few of them. The most important one is probably coincident, and this constrains a point onto a line or another point. Now tangent will make a line tangent to a curve, and that just means that the line will intersect only one point on a circle and is perpendicular to a diameter of the curve. Fix makes an item stationary or just locks it in place. Concentric makes circles, ellipses, or arcs have the same center point. So on the sketch, make two lines like I am, make them not connecting and kind of in a V shape. Purposely try not giving them any constraints because we're going to practice adding those constraints. Although Fusion 360 can automatically apply certain constraints depending on how you draw these sketches. So use the coincident constraint to connect these two lines together with one point. Use the perpendicular constraint to make these lines perpendicular to each other. And then use the horizontal vertical constraint on only one of these lines, just like I am here. So if you were to apply this to both of the lines, then Fusion 360 would throw an error, an over-constrained error, because they're already perpendicular. And that error doesn't actually cause any problems, it just is there to tell you. Now finally, constrain the vertex of these lines to the midpoint of that projected line, using the midpoint constraint, which is that triangle. All of these constraints could have been done automatically when you drew them, but there are many times where you have to add constraints manually, so this is just good practice. So now let's make these two lines equal using the equal constraint. And this is one constraint that Fusion can't automatically do. So hit D for dimension to set the length of one of the lines to center underscore RAD for radius. And now we're going to make a circle using C. So first select the vertex of the lines as the center of the circle, and then select the end of either of these lines as the radius of the circle. It doesn't matter which because they're both the same length. And when you selected both of these points, you may have noticed a small blue box. This indicates that Fusion was trying to automatically apply coincident constraint, and you can always select the symbol of a constraint and delete it after the fact. And by the way, this arc that we made with the circle, we could have just used an actual arc function. Once you have all that done, you can finish sketch. We've used extrude before, but if you don't want to extend your sketch in just one direction, there are other methods. One of these being revolve. So under the create tab here, select revolve, or you could just use S to search for it. For the profile, select the quarter circle we made. With Fusion 360, you can select sections of your sketch opposed to the entire thing, so we don't have to revolve an entire sphere, we can just do the hemisphere that we want. Now for the axis of the revolve, select that vertical line of the sketch. Now 360 degrees should automatically enter, but if not, just type 360 and then hit enter. So what we just made actually is not where we want it to be. Technically, we should have created the hemisphere after making the cylinder, which we're about to make in the center, but this will allow you to use the move feature. So hit M to move and select that hemisphere we just made. Change the move type to translate like this, and translate just works better if we need to change any of these variables. Now we can translate the Z distance by center underscore HEI, again for height. And sometimes you will need to hit the capture position button after moving an object just to ensure that it stays where you put it. Now just another reminder to save. So before our next sketch, I'm going to need to explain the difference between regular lines and construction lines. So in this example here, I've separated a square with just regular lines. If I were to extrude this sketch, I'd be able to select the quadrants of this square. If I wanted to extrude the entire thing, I'd have to select all 4 sections. Now in this example, I separated a square with just construction lines. And construction lines are used for reference, and they will not be seen as separate sections, so they don't affect that extrusion. Or if I were to extrude the square, I can't select just the quadrants, but I can easily select the entire square. So now going back to our model, create a sketch on the face inside the hollow fan base, the face right here, but make sure you still have the fan component selected. So make 2 construction lines, use X and L. X is for construction, and L again is for line. And create these lines from the midpoints of the edges of the base, going across, making a cross shape. With these lines, we can reference the exact center of the square without interfering with the extrusion of the body. So the hemisphere is blocking our view of the sketch. So on the left-hand side of the screen, you can drop down the fan component if it's not already, and then the bodies folder, and then make the hemisphere body invisible. And it should be called body 1, I believe. And now we can create a circle using C and start it at the center of the base. If the circle perimeter is dotted, then you're going to have to hit escape and then X to stop creating construction geometry, and then just make that circle again in the center. Now type in center underscore DIA for diameter. And don't forget that if you already placed the circle, you can use the dimension tool to define the diameter after it's placed. So click Q to press pull the center, and then we're going to make that a height of center underscore HEI, again for height. And make sure that the extrusion operation is set to join. Make that hemisphere visible once again, because sometimes it won't let you join those two bodies if one of them is invisible. And then once you finish extruding that, save the model, and you're done with part 1. So we got through many basic functions of Fusion 360, and a few more complicated ones too. Part 2 will include more complex features like lofts, tangent planes, patterns, and more.